Environmental pollution and control air pollution. Sources and types of pollutants. Natural sources. Volcanoes emit sulfur dioxide, particulate matter and other gases. Wildfires release carbon monoxide, nitrogen oxides and particulates. Dust storms generate particulate matter. Biological sources produce pollen, spores and microbial antigens. Anthropogenic sources. Industrial emissions from factories and power plants release sulfur dioxide, nitrogen oxides, carbon monoxide and particulates. Transportation through vehicles emits carbon monoxide, nitrogen oxides, hydrocarbons and particulates. Agriculture produces ammonia, methane and pesticides. Residential heating and cooking release carbon monoxide, nitrogen oxides and particulates. Primary pollutants are those that are directly emitted into the atmosphere. Some common examples include sulfur dioxide, nitrogen oxides, carbon monoxide, volatile organic compounds and particulate matter. Secondary pollutants, on the other hand, are formed through chemical reactions in the atmosphere. Examples of these include ozone, secondary particulate matter, and components of acid rain like sulfuric and nitric acids. Criteria air pollutants are a group of air pollutants that are regulated by environmental agencies due to their potential to harm public health and the environment. These include particulate matter, both PM10 and PM2.5, ground level ozone, carbon monoxide, sulfur dioxide, nitrogen dioxide, and lead. Sampling and monitoring of air pollutants. When it comes to gaseous pollutants, we have a few key techniques at our disposal. Continuous monitoring systems, passive samplers, and active samplers are commonly used. The instruments for these techniques include gas analyzers, such as non-dispersive infrared for carbon monoxide and chemiluminescence for nitrogen oxides. For particulate matter, we employ techniques like gravimetric analysis, optical methods, and beta attenuation monitors. Instruments used include high-volume samplers, TOM, which stands for Tapered Element Oscillating Microbalance, and particle counters. Now let's talk about sampling parameters. The sampling period can range from short-term, which means hours to days, to long-term, spanning months to years. Sampling frequency can be continuous, daily, or periodic. The duration of sampling is determined based on the type of pollutant and the monitoring objectives. Indian National Ambient Air Quality Standards, or NAAQS, were established by the Central Pollution Control Board, commonly known as CPCB. These standards set permissible levels for a variety of pollutants, including PM10, PM2.5, sulfur dioxide, nitrogen dioxide, ozone, carbon monoxide, ammonia, lead, benzene, benzoate, pyrene in its particulate phase, arsenic, nickel, and others. The impact of air pollutants is quite significant. On human health, air pollutants can cause respiratory and cardiovascular diseases, lung cancer, asthma, and other chronic illnesses. Vulnerable groups such as children, the elderly, and people with pre-existing health conditions are particularly at risk. When it comes to plants, air pollutants can lead to reduced photosynthesis, leaf damage, reduced growth, and yield losses. And let's not forget about materials. Air pollutants can cause corrosion of metals, degradation of building materials, and damage to cultural heritage sites. Acid rain. The formation of acid rain occurs when sulfur dioxide, SO2, and nitrogen oxides, NOx, react with water vapor in the atmosphere to form sulfuric and nitric acids. The impacts of acid rain are quite significant. It leads to soil acidification, water body acidification, damage to aquatic life, and forest degradation. Dispersion of air pollutants. Let's start with the mixing height or depth, which refers to the vertical extent of the atmosphere in which pollutants can be dispersed and diluted. Then we have lapse rates. The environmental lapse rate is the rate at which temperature decreases with altitude. On the other hand, the adiabatic lapse rate is the rate of temperature change of a parcel of air as it moves up or down without exchanging heat with its surroundings. Moving on to dispersion models, the Gaussian plume model assumes a steady-state plume from a continuous point source, describing pollutant concentration as a function of downwind distance, crosswind distance, and height. The line source model is used for pollutants emitted along a line, such as road traffic emissions. Lastly, the area source model is used for emissions from large areas like industrial zones or cities. Control devices for particulate matter. First, we have the settling chamber. The principle here is that it uses gravity to remove large particles. The working mechanism involves air passing through a chamber where particles settle out due to gravity. Next, we have centrifugal collectors, also known as cyclones. The principle is that they use centrifugal force to separate particles from the airstream. Air enters a cylindrical chamber tangentially, creating a spiral motion that throws particles to the chamber walls, where they fall into a collection hopper. Then we have wet collectors or scrubbers. The principle here is using a liquid to capture particles. The working mechanism involves air passing through a liquid spray which captures particles and removes them from the airstream. After that, we have fabric filters or bag houses. The principle involves using fabric bags to filter particles from the air. Air passes through fabric bags that trap particles on their surface. Finally, there are electrostatic precipitators, or ESPs. They operate on the principle of using electric charges to remove particles. Particles in the air are electrically charged and then collected on oppositely charged plates. Control of gaseous pollutants involves several methods. First, adsorption. This principle uses solid materials known as adsorbents to capture gases. The working mechanism is that gaseous pollutants adhere to the surface of the adsorbent material, such as activated carbon. Second, absorption. Here, the principle involves using liquids to capture gases. In practice, gaseous pollutants dissolve in a liquid absorbent, like water or alkaline solutions. Third, condensation. This method uses cooling to convert gases into liquids. Essentially, gaseous pollutants are cooled until they condense into liquid form. Lastly, combustion. This principle burns gaseous pollutants to convert them into less harmful substances. There are two types: thermal combustion, which is high-temperature oxidation, and catalytic combustion, which uses a catalyst to lower the required temperature for combustion. Indoor air pollution has several sources, including household chemicals, building materials, tobacco smoke, and cooking and heating appliances. The impacts of indoor air pollution can be quite severe, leading to respiratory illnesses, allergies, and other health problems. To control indoor air pollution, measures such as ventilation, air purifiers, and using less toxic materials are essential. Vehicular emissions and urban air quality are closely linked. The sources of these emissions include exhaust from cars, trucks, buses, and motorcycles. The pollutants involved are carbon monoxide, nitrogen oxides, volatile organic compounds, particulate matter, and greenhouse gases. Control measures to address these emissions include setting emission standards, using catalytic converters, promoting electric vehicles, and encouraging the use of public transportation. Improving air quality involves a combination of monitoring, regulatory standards, and technological interventions to reduce emissions and mitigate their impacts.